Okay, sometimes you're given a triangle to find exact trig values from. Sometimes you're given points to find exact trig values from. In this case, we're given points. We want to find the 6 trig values based upon this point, the point 5, 12. But this is your x-axis and this is your y-axis. We would go 5 units to the right. We would go 12 units up. And that would be our point. Okay, so what's happening is we have an angle formed with the positive x-axis and from the origin up here to this point. Okay, there's the point 5, 12. Okay, so this is the angle that we're talking about. The angle, our reference angle, and we can drop down this perpendicular so that we have a nice triangle. Okay, because you can't find the trig values here without having right angles. So yes, the x value is 5 and the y value is 12. That says 12, I promise. So in order to write down the trig ratios, we need to calculate the hypotenuse, okay, which might be the radius of a circle here. So if I'm going to use Pythagoras to do that, 5 squared plus 12 squared equals radius squared, and with a little bit of adding and square rooting, I get a radius of 13. 5, 12, 13 right triangle. Okay, so our 6 trig ratios, we start with sine, cosine, and tangent. I'm going to write right here over the top of this. Sine, cosine, and tangent. So the sine of this angle is opposite over adjacent. Sorry, hypotenuse. 12/13. Cosine is adjacent over hypotenuse. 5/13. And tangent is opposite over adjacent. 12/5. So those are your 3 basic ones from geometry. Now we have the next 3 from pre-cal. So the cosecant. The cosecant is the reciprocal of the sine, so hypotenuse over opposite side, 13/12. The secant is the reciprocal of the cosine, so hypotenuse over adjacent side, or 13/5. And the cotangent is the reciprocal of the tangent, so adjacent over opposite, 5/12. So anytime you're given a point, okay, on a Cartesian grid, you're able to draw that dot and you're able to figure out your radius and then write down the 6 trig functions from there. Okay? So I'm going to erase all this so we can move on to the next one. So here we have the point at -3, +4. So we go -3 in the x and +4 in the y. So we have a second quadrant point. Okay, the angle, of course, would be formed with the positive x-axis. See if I can make it go through that point. Not really. So that would be the angle we're talking about. But that's not the angle we use for our trig. We use the reference angle, which is formed with the x-axis. So this is the ugly looking triangle that we're going to use to do our trig ratio. Okay, this is our angle we're using, reference angle. So we have -3 as the x direction, we have +4 in the y direction, and when we use Pythagoras, we get a hypotenuse of +5. Okay, it's important that when we're in the second quadrant, we remember that the x value is negative. The y value is positive, and the radius will always be positive. Okay, so we can write down our 3 easy trig ratios, the sine, the cosine, and the tangent. So the sine of our reference angle, sorry, that should not be theta, that should be alpha. Erase all that stuff. reference angle. Sine is positive 4/5. The cosine is adjacent, so negative 3/5. And the tangent is opposite over adjacent, so 4 over negative 3, or negative 4/3. Okay, so in the second quadrant, the cosine is a negative value, and the tangent is also a negative value. Okay, they change based upon what quadrant we're in. So the cosecant will mimic the sine. It will also be positive over here, 5/4. The secant will mimic the cosine, so negative 5/3. And the cotangent will mimic the tangent, negative 3/4. So in each of these cases, whenever we have a negative secant and a negative cotangent, you need to know that the negative sign only belongs to the x value. Okay, the hypotenuse will always be positive, or the radius will always be positive, no matter what quadrant these points happen to be in.